already started that with Mrs. Baker, so we're going to continue that with Mrs. Baker. All right? Hi, Keelan. Come on and sit down. You're just in time. We've got your desk in the lavender group right here. It's good to have you. Keelan's going to be joining us now, and we're a little off our schedule today. As you can see, we're right here today, so it's really nice to have you in your Valentine. Wow, I would like those. Your Valentine leggings there. Do you want to do some calendar with us today? Okay, I'm glad you're here to do that. Okay, everybody, so let's start off with a warm-up with our word that we have up here. The word is function. A function is a rule at work. Function. Say it to your puffball in a mouse voice. Function. A function is a rule that works. Function. Say it to your thumb in whatever voice you like, but not a very loud voice.
Function. A function is a rule that works. Function.
Wow, you all seem to want to say it in a very low voice.
Yeah.
I also said it in a very low voice, because you know I can't sing quite yet. So Keelan, we don't have everything that you need, but I think Madison would share with you today. Would you share with Keelan today? Okay, we're going to be building some stuff with those tiles, and I know that you like to build stuff with tiles as well. So our February calendar here has to do with building patterns, and you guys have already learned quite a bit about the pattern making with your pink calendar grid that you guys have there. So can I get some volunteers? Maybe I'll pull out some colors and spoons for you guys and see if anyone wants to describe some of the things that you guys have been talking about with our calendar grid. I have not done Blue Group yet. Would anyone in Blue Group like to talk about days 1 through 13 on your calendar grid? Anything that you've learned? Thank you, Elias.
Every input or every output number is plus by 3.
Okay, every output number is added or has 3 added onto it. Does anyone agree with that? Does anyone have any other information they can add about that? How about someone from the red group? Can you add on to what Elias said about the adding on of 3?
We learned the input you added.
Can you say that again for me?
For the input number, you added 1 number.
For the input number, you added 1 number. Can you come up and bring your paper up and put it up on the document camera? Because I'm a little confused about what you mean with that pattern. Let's see if you can put it up here and explain it a little bit. So Elias said that each number is, say it again, Elias, is added on by 3. And then is he added on to the idea that something about 1. So can you give me a little more information about that?
Like in the input number, it's 1, 2, 3, 4, and it just keeps adding 1.
Okay, so it's like, what do you call when you just count by 1, 2, 3, 4, 5, 6, 7? Anyone know what you call that counting way? Counting by ones, or is there another name that you guys have talked about with that? Shauna?
I just forgot about it, but it's on the tip.
Oh, okay, well maybe if you remember it, we can get back to you on that. Okay, so she says the input number is just sequential counting. 1, 2, 3, 4, 5. And then you said something about the output number. Can you come up and use her chart and show us what you meant by the output number so we have a visual for that? So go down a little bit and prove that for us.
Because 10 plus 3 is 13. To get 13.
Okay, keep going down because you proved it once. Does it repeat all the way down to the 13? Okay, prove that to me. Is there a way that you know that?
Yeah, because 37 plus 3.
Do you guys agree with that in the output each time those numbers go up, we're adding on 3 with that? I do agree with that. Thank you. Izzy, why don't you grab your paper back? And then let's get anybody in the yellow group. Do you guys have anything about, any observation and predictions about what you notice about the patterns that we've had now between the 1st and the 13th? Hunter T.
Every time
You want to put your paper up there so we can see it? I mean, I think we all have very similar things that are on our paper for our observations and predictions, but we're just kind of confirming now what we've written down.
so every time like 1 and 4 plus 3 or sorry plus 1 times 4.
It's okay, try it again. You're just, it is a little confusing there, but let's try an observation that you're pretty confident about. Maybe number 1 is something that you're not confident with explaining.
6 and 19 times 3 is 18, but if you add one more, it's 19, and it goes all the way down, plus 1 times 3.
So are you making the connection that this is a pattern that's going with this number right here? So what's that number? Does that number relate to that number? How does that number relate to that number? How does 9 plus 19 relate to the number 28? You want to get someone to help you on that?
If you add times 3, it would equal 27, but plus 1 is equal to 28.
Well, you already did that one. So the question I was asking was, where does this number 19 come in? Because I think, do we understand the pattern times 3 plus 1 with the number that's on the calendar grid? So where does the addition number come in? Because it seems as if you have 2 separate operations on your observations and predictions. Is anyone kind of with me on that? Show me that you agree with me. Hunter T, can you pick someone that's agreeing with me to help you explain, well, what's the connection between 9 plus 19? David, come on up.
What I know already is that if that was 20 and that would be 29, but minus 1 because it's 19, so it would be 28. So it's 9 plus 19 equals 28.
Oh, that makes sense to me now. Does anyone see that connection? Shauna, please lay those flat. Thank you, dear. That we have 2 observations and predictions here. You've used different mathematical, what do we call additions, some different mathematical thinking. So you have one way we can get to the output number of 28. And you have another way we can get to the output number of 28. Shauna, is it true, lay those flat, that we can both add repeatedly and multiply quickly to get the same number for 8? How could we add repeatedly to get 8?
Maybe like 2s or 4s.
2s or 4s.
Numbers that are lower than 8.
And then can we also multiply to get to 8? What would we multiply to get to 8?
We do 2 times 4 or 8 times 2.
Or even 1 times 8 maybe? So what I see up here that you guys have started recording is that you have a way of addition and multiplication to get this function. A function is a rule at work. Function. And you have another function of adding to the calendar number. And we call that function. A function is a rule at work. Now, has anyone maybe asked themselves why and how is this something that connects to the real world? Because I always want to know how math connects to the real world. So I would like us, thank you boys, you guys can sit down. I would like us to, yeah, you can take your paper, to think of a real-world example that is a function machine. Because again, function. A function is a rule that's at work. Function. A function machine is like a washing machine. What's the function of a washing machine? Yes.
It washes and dries your clothes.
Oh, it doesn't dry my clothes. What dries my clothes?
The dryer.
The dryer dries my clothes. So there's a totally different function for the dryer. But a washing machine
Gets it wet.
gets the dry clothes wet, and then what's it do with it, Zoe?
It gets it wet and it gets clean and gets it clean.
And then when I open the door, the clothes aren't dirty anymore. They're absolutely clean. So can you guys put your heads together, tooties up, and I would like you guys to think of some real world examples of different function machines. Go.
A vacuum cleaner. A vacuum cleaner, a washer, dryer. I was about to.
Freeze for a second.
A washer, dryer, a tack machine.
Thank you. I hear some really good machines, but I don't hear you guys talking about the rule at work. So if you name a machine, like I heard vacuum, you better tell me what's the rule at work in that machine. Because you gotta be able to explain it and prove that that machine actually has a function, that it's not some worthless piece of machinery that we have in our cupboards that we never use. All right, back to it.
I'm thinking of soda machine because if you have to pay $1 and put it in, and then you press what soda you want, and then it comes down, and then you grab it and then you drink it. That's how vacuum cleaners it calls for for a phone, you could call anyone. Only if you could call and their contacts.
Oh, and drives it work.
There's also a sink. Sink washes your hands and washes dishes and all of those stuff.
5, 4,
because when you cut down wood,
function. Function is a rule at work. Function. All right. Clean group. Number 3. What's your machine you guys thought of? Put your heads back together if you need more time.
A dishwasher,
Oh.
it cleans your dishes, and when the dishes come out, they're dry.
Oh. So a dishwasher has 2 functions it does. Can you turn off the drying function on a dishwasher?
Yes.
Yeah, they can do an air dry, can't they? So dishwashers actually have lots of different functions. They have sanitize and air dry and pots and pans, but yes, you are right that the dishwasher is an example of a real world function machine. Cole, can you come up and pick out a color and a spoon, please, for me?
Red 2.
A bowling alley. The machine that brings the ball back to you.
Ooh, do you know what you call that, Austin? Was that your idea? I think it's called the, well, there's the pin setter, and then what should we call it, Austin? Because I don't know, I don't bowl at all.
Thingamajigger.
We're not calling it the thingamajigger. No, we cannot call a specific machine a thingamajigger. That's quite silly. We have a thingamajigger for every lift up here. thingamajigger, thingamajigger, that thingamajigger. That's my laugh of the day. Let's see. How about the ball bringer backer at the bowling alley?
That's what I was gonna say.
There's some alliteration for you.
That's what I was
Okay, ball
The ball
bringer,
backer.
backer
That's a
at
lot of
the
B's.
bowling alley.
That's a lot of We should call
You,
it
as Jacob said, you throw the bowling ball. Is that what you call it? I guess you throw it. Roll the bowling ball. It knocks down the pins. The ball goes into that little carrier, and it gets brought magically back to you. Jacob, can you pull out a color and a spoon, please?
Blue. One. I think a calculator.
Oh, what's that function?
You can't figure out a problem, and then you type in the problem, and it ends up.
What does it do? What's a calculator do?
It figured it out.
Yeah, but how? Like,
It adds it.
calculator adds and multiplies and divides. But do you have to be part of the machine to get it to work?
Well, yeah.
Yeah, what do you have to use?
You have to press the button.
You have to use your fingers, don't you? Because we can't just stare at a calculator. Unless, of course, it's on our phone and we can speak it, right? Okay, you're gonna come up and pull out one. We've got 2 more spoons in here, but I don't know if we have a number 5 in here. Do you have a number 5? Purple 5. Solve that problem. Can I have that, please? I think a friend just gave it to you and you're already picking it apart.
We got like a microwave.
Ooh, what's a microwave do?
It like cooks up your food.
It cooks and it even sometimes defrosts, doesn't it? All right, you got one more color and spoon in there to go pick out. And 3 colors left.
Yellow for a vacuum cleaner. It cleans up your floor when your floor is dirty. It cleans up all the germs on the floor.
Dirt on the floor, yeah. How many of you also thought of a function machine that did not get recorded on our list? I was thinking that maybe as part of literacy, we could make a list in our journal that would be an additional list of function machines. Because again, let's do our word, function. A function is a rule, that's that word, function. And I wanted to give you the real life connection about why this calendar grid is up here. Because you know, it's kind of hard to think about having this little machine here, but this machine has something that's called a program. Can you guys think of anywhere else that we've heard the word program? Where have you heard it, Izzy?
Like sometimes I hear like different programs that you can like either like play games on a computer or something.
Oh yeah, on a computer. I agree with that. I've heard computer programs. Have you ever heard of the word program anywhere besides a computer, Keelan?
A TV program.
Definitely. How many of you have your favorite programs on your TV? Well, programs, you know, that program on the TV and the program on the computer, they have rules at work, don't they? Because if we're going to turn on the, you know, let's see, what's it called? The Simpsons, they have rules at work. They've got the characters and the episodes, and if something else happened or Homer Simpson looked like something else, we would be confused, right? That's not the person that we would visualize with that one. So your calendar grid, let's go ahead and have someone from the Lavender group. Let's do Keelan. Lavender group, can you go turn around Valentine's Day for us over there? Thanks, Keelan. Let's do a prediction. Keelan's going to hide it momentarily, so don't let us see it. Pull it out. Now hide it for a moment. I would like you to look at 13, and I would like you to predict the output number that we are going to see. Go like this when you think you know the number Keelan will be revealing. All right, Keelan, flip it around. Who'd you call on, Keelan?
Sean.
Who?
Sean.
Oh, sorry. I thought I heard somebody Shauna, what do you think is going to be on there?
Output number would be 43.
Kaylin, is the output number 43?
It's like winning $1,000,000.
Okay, go ahead now. Let's write down our rules that we've talked about. You guys have repeated addition, but you also have a multiplication and an addition that goes together. Thank you, Cole, for fixing that. Because in 4th grade, we want to get beyond doing repeated addition, and we want to start using multiplication with some of our stuff. Can you check hers that she did it correct, Keelan, right there, since you don't have a paper? Sorry, I'm using your desk. All right. So let's go ahead and take out that white paper now. We have this little guy called function machine. And who would like to be the reader of that note that is in there describing hi? Zoe, can you read that nice and loud and our friends will follow along?
Hi, I'm a function machine, and I can transform numbers into all sorts of ways, depending on how I've been programmed. Once I've been given a program, I keep doing the same thing to do any number you put in.
Keep doing the same thing every time you put it there. It's a rule. It's the program of this little guy. So here are 2 examples of this function machine's work. And he would like you, or she, should it be a he or a she?
He.
Okay, well, raise your hand if you'd like our function machine to be a he. I think that is majority. He wants you to figure out how he was programmed to do each job. Then you're going to fill in the missing numbers in our T-charts. So I would like the following puffball groups to do job 1. Red, lavender, and purple, and yellow. You are just going to focus on job 1 and the program of that program. Job 2 is going to be green, pink, and blue. You guys are just going to do your heads in, chat about the rules for job 2, and decide what the program is. Now let's link it to your pink sheet. This right here is the program, isn't it? It's the description of how we got the input and the output. Are you ready? Who's doing job 1? Raise your hand. Thank you. Who's doing job 2? Raise your hand. Thank you. It's going to get a little noisy in here because you're going to have heads in chatting about your program and the function of that machine. 3, 2, 1, go.
It goes up to 1.
What are you doing? You already did that.
Oh, wait.
Oh, there's missing numbers. What are you going to do if there's missing numbers?
I see the output from 3, 4, 5, 6, 7. The program is plus 2. The first box in the output is 27, and the box in the input is 150.
So we're just adding 2, so it's 146. So the output you're adding 2, and the input you're basically subtraction. So we're gonna add 2 on this one. What's my program? Plus 2. And then this one's 1, 2, 3.
Warriors, raise your hand and show me how many minutes left. No more than 3. All right, I'm going to give you 2 more minutes to figure out the rules, the input, output, and how you would describe that program. Go.
This program is doubling and counting by 2s in the output. 10 and then 20. And the input is just going by 1. So 1, 2, 3, 4, 5, 6, 7, 8,
Well, let's take a look at those.
10. It's going by 2. It's all 2. So the program is going to 2. Final answer? Anyway, so this would be 6. 10. I think no, 20. 2 times 2. 20. Yeah, so 5 times so that would be a 2. And that would be a 2. And this one was 62.
Function. A function is a rule at work. Function. So we had job oneers and we had job tours. Are you job tours done? Okay. Job oneers, are you almost done? No. Not quite. This group was having a little difficulty. How many of the other job oneers might have an idea? You finished? Okay. So if you do not have an idea about that function machine, this is our time to share our ideas and correct our thinking in case our pattern might have been done in a different way. Okay? This was our warm-up. Because on the other side, flip it over really quick, let's take a look at the other side. On the other side, we have another function machine. This is where our tiles are going to come into play. And this rule follows the rule you have on the February calendar grid. Have you made these yet with tiles yet? No, that's what we're going to be doing today. Can you show your function machine that's listed on your pink calendar grid by doing a example, making what's called a picture? We've been doing lots of words, haven't we? So flip it back over to side 1. And since you guys weren't a little confident, I won't call on you right away, but let's see what purple number are you next? Purple 3. I guess I've been pulling 3 out a lot, right? Let's do a different one. Purple 2. Solve that problem. Why don't you pull your paper out and go put it on the document camera. Yeah, can I have that, please? I don't know if you're quite ready for it.
So what I did on the output was that I added 2 to 27 like we were doing on our paper, which was 27.
Okay.
And then on the input, I minus 2 from 145, and I got 143. Then on what's my program, input was +2 and the output was -2.
Okay. Who are all my job oneers? Do you guys agree with that? And then, how about double hands up if you have a different way to explain it, job 1. Different way to explain it. You have a different way? Okay. Job tours, do you agree that that's how they would get their input-out machine? I agree as well. All right, all of our job tours, who are they again? All right, let's do green, number 2. Green 2. Who's going to go put their paper up there? Oh, Alexis, go for it, girl. All right, so it looks like you don't have a program down there yet. Can you go back to your group really quick and write down what your program is before you put it up there? So can you guys do heads in, 2Ds up, please, to get the program written down? Because it looks like you have a job, input, output. input was 10 and your output was 20. And how did you get that? What's the program that got you there?
I added 10 plus 10.
And then you also did another way down there, I see. You could have also done,
10 times 2.
because that gets you the same thing. So how did you get the 15 and then the 124? Input 15, output 124.
I minus this one.
Added by 2s. Do you guys agree for job number 2 that that is the input output? Who's my number 2s? We agreeing here? We agreeing over here? So Blue Group has some disagreement. So do you want her paper up there or do you want to bring another paper up?
I'll bring it.
You're gonna bring your paper up? Okay. So bring your paper up and we'll put it up there. And let's see what their thinking is, because they decided that they have a different pattern.
So we did 1 times 2 equals 2, and then 2 times 2 equals 4, and then going on, and then 10 times 2 equals 20. But then we took away half of 124, and we got this answer. So the program would be times 2.
So should we prove that by doing 62 times 2? Why don't you prove that? You can borrow my pencil or my pen. Right down there. Is 62 times 2 124? Is that the way we can check it? It checks. So let's see maybe what your misthinking was. You guys, if you doubled 15, what would 15 would have been? Let's double 15, you guys.
30.
30, that's not enough, is it? No, and I think what ended up happening here, did you guys notice that on this function machine right here, that they skipped many numbers? I mean, they went from 5 to 25.
Yeah.
Yeah, so you kind of had to remember that not all the numbers were listed, were they? Is that maybe what got you a little confused, you guys? All right, did you guys fix that all? Perfect. Okay, flip it over, because now we're going to go into our pink calendar grid. And before we actually build these, somebody in your group has a yellow Post-it note. Where's that yellow Post-it note? And you should have your colored pen for your puffball. Everyone got their colored pen? All right. What I'd like you guys to do before we dive into the function machine that goes with our calendar grid is you see that there are several days of our calendar grid that we have yet to uncover. I would like you guys to decide on a day of February and what possibly might be, we know what the black number is going to be, don't we? What might possibly be the output number. And it is okay if you in a group if somebody picks the same calendar grid. Questions on that? You're making a prediction, writing down what the output number will be. Everyone, 3, 2, 1, go.
I think 15.
You had a pen. I gave 1.
Let's
Solve that problem. Solve that problem.
We got the input number is 26. All in favor of 15, raise your hand. 15 and 46.
You didn't do that day? Okay, so write it on your Post-it note.
Well, we know the black 15. I think it will be 43 because it's just adding 3.
Well, put down your math that proves it. What observations do you have?
Really, it's 6.
You guys can actually put it on here. You can do that. Okay, these papers keep falling all over. Oh, yeah. Okay.
So it's times 3 plus 1. But what is it? Plus 5. I know. This says there's I didn't like so I did something by plus something will get so it will be 31 plus 31 times
Okay.
plus 1.
As soon as your group has their prediction, oh Hunter, you just have to write the output number on it.
Oh,
What do you think the output number is going to be? And that's why you have your brown.
well, we're prepared.
Erase it here. And just write your output number on it. This would be very good. Right there. And then you're going to go, yeah. 15, and what's the output? All right. Bring it up there. We're not going to what it is. Okay, let's everybody go put a Post-it note up there. 5, 4. Are you guys going to 3. 2. Okay, go put your red, where is it going to go? 15 through 28. Do you guys have one in pink? What day of the week, what day of February are you going to go stick it on? Okay, go put it up there. You guys have your day that you're putting up? Okay, write it in a blue pen. Okay, looks like we're waiting for purple group. Lizette, write it in your purple pen. That way we know it's the purple groups. I'm gonna give you a new one.
I do this very same thing.
What day of the week is it? But that's okay. You can leave that there. Yep. You're gonna put it on the 18th. Well, what day of the week did you do? How about you just cross out the ones you don't want and then go put it on the day that you do want. That group over there, they picked 3 days of February. Oh, they're overachievers over there. No, let's just pick one. But nice question, Hunter. Alright, just waiting for the green group. This will be interesting to see if our predictions actually come true, and we'll get to verify them when we actually come to those days of the week. Alright, now is the time you've been waiting for, because you have been sitting at your desk with your tiles all morning wanting to know how you're going to use those tiles. So everyone should be on the other side of the introducing the function machine.
Yes.
Alright, it basically says the same thing as the other side. It wants you to figure out the rule of the function machine. So if we take a look at this first T-chart here, it has input number 1. And the rule that you have told me that February follows is times 3 plus 1. And that's the picture that they've used. Can you guys, do you see how the middle one is a darker color?
Yeah.
And the other ones are a lighter color or white?
That's the one.
Oh, David's already ahead of me. So what I'd like you guys to do in your group is I would like you to build 1. I'd like you to build 2 and put it beside it, and build 3 and put it beside it. David here has green in the middle, yellow on the outside. It can be any combination.
I already did the first one. I already did the first one, so.
If we run out of yellows, you can go get more. We're gonna try and build.
We're gonna need more yellows. Number one. Or we can do it like number. Here, I'm gonna go get some more. Or we can do it like this. You know what I'm saying?
So you're making a really pretty pattern, but that's not what you should be.
Okay. I got some more yellows.
So you're making a really pretty pattern. That's not.
Are we all gonna be making?
You're not supposed to do that.
It's fine. It's the opposite way. It's a way of not needing.
Your pattern has to match. Okay?
So, what, this one? 1, 2, 3.
Okay, did you get all of those?
We're gonna add.
Who's doing number one? Oh, is that number one? Okay, line them up. When you're all done, you want to line them up side by side. Okay, wait a second, hon. Your pattern is completely different than that pattern. You have a bunch of green. Yours has to match
I
their
already
pattern.
did the first one.
Yeah, so if they have green in the middle, you have that.
I think that the dark shade has to be red because it's dark and the light shades have to be yellow because yellow is harder to see because it's more white.
Thank you, Lavender Group. Really quickly, I need to give a reminder. Your pattern, whatever you build, has to match, sorry dear, the rest of your group. So if he has a green tile in the middle and blues around, Jacob can't put a blue tile with green all around. They're gonna match the pattern. Can you guys double check that you have the same tile pattern as the rest of your group? And by now, purple group, you should only have 3 formations built, not 5, just 3. Can you fix that, please? All right, go.
I'm going to do the big one.
Thank you, red group. Where are you gonna put that one?
I'm done.
You did number 2. I did number 3. You're going to do number 1. You have to do red. You have to do red, then yellow all around.
Okay. Green. I'm gonna line them all up so that we have all of them built.
Number 3.
Maybe.
I mean number 1.
There. Now,
Yeah, we have to have an apple on your head.
Right. Green group, are you done? Yes.
Okay,
Done. Purple group, are you guys almost done?
we finished.
Okay, so it looks like you have 2 colors in there. Green should be in the middle. What will be on the outer edges? Red. Can you help her with some red over there, Shauna? Looks like Keelan's getting some more colors. So you have number 1, and then you have number 2. And you're building number 3. Okay, can you line them all up? Let's get these cups out of the way. So number 1, 3 more of it all over right there. And then number 2. And then you guys can move number 3 over there. Keelan, I bet we have enough. We're almost done.
So that just comes back. Okay,
then one more.
Function. A function is a rule that works. Function. Drop the tiles, cross your hands. All right, boys and girls, you guys should have built the number 1, number 2, and number 3. I'll wait for you, Hunter T. Your hands should be crossed. What it says on number 1 is, what do you notice about the 3 tile arrangements shown above? These tile arrangements, I said, have something to do with day 1, day 2, and day 3. This might help you with patterns that you notice. How did you get those patterns to work? And maybe some other questions could be, can you prove what you noticed? Number 2 says, after you get done writing your number 1, let's cross our hands again. I see some of you building. Number 2 says, how would the 4th and 5th arrangements in this sequence look? Build them and share your thinking with your group. So the 4th one you'll build together, and the 5th one you will build together. And you'll draw them in the boxes. Now I'm going to show you a quick way to draw them so you don't have to go all crazy. See how that's a quick little sketch right there? In case it gets really long and you can't draw it in. Hunter, okay? Cross your arms, please. Can't draw in all of your boxes. That is another choice. Okay? Nod your head if you understand. Shake it if you have a question. Oh, Lily, you're going like this. All right. Your job is to write about the patterns that you drew. Heads into these up. Chat. Go.
Okay, so what I noticed is over there you're adding 3, 16 plus 3 is 19, and over here you're adding 3. 1, 2, 3. You're adding 3 more. This is the number. Yeah, so you're adding 3 more. So when you add 3 and that, you're adding 3 on those ones, and you add 3 tiles, 1, 2, 3, and it gets you a bigger one. So what should we say?
By 1 every time.
Just times 3 plus it should be the same 1 plus and that's adding 3 more times. The first one should be the same as the 3 more like that.
It adds on 1 to each side.
The 4 was number 2.
I have a really good clarification that I stole from the red group. The red group has called these parts the sides and these parts the top. So in your description, you could use sides and top to help with a more detailed description if you want. Okay, go. That's perfect. Write that.
It adds 3 tiles.
When you guys have finished number 1, you may go on to number 2.
It adds 3 tiles. Whoa. Same thing you
Better ask your You guys run out of reds?
Yes.
Okay.
And then we're getting into the bigger numbers.
You're getting to the bigger number. So what did you guys write down for number 1? I don't see anything there yet. So Shauna? drop those down for a sec. Before you guys go into the next one, I want you to write down what is it that you notice about the pattern on these arrangements. How does it grow? Can you do that first before you build anything? Although really nice job on what you're building is.
1, 2, 3, 4, 1, 2, 3, dark green, 1, 2, 3. So we do this is add 3 tiles each time on the calendar. So you add 1, 2, 3. And on the calendar you add 3 days.
Well, where's this one now? What happened to them? I still would like to see them. Well, actually, they're not just mixed, they're all of yours. So, Purple Broom, can you rebuild day 1, day 2, and day 3 for me? Stop.
Day 3.
Can you rebuild day 1, day 2, and day 3? And then you might have to go get more tiles to build on day 4 and day 5.
I get it.
I don't want you to get destroyed. Okay,
I did it. I think it's adding 1 every time.
I get it.
Okay?
I'll go to rebuild. I already built it. So I'm gonna go get some more tiles. I thought it was one every time
I did. I think it's adding 1 every time.
You might not finish today. 1 minute left. You might not finish today. Well, where's day 1, day 2, day 3?
We're still 85.
Hey, I said 50. 1, 2, 3. I see you. Do you see me?
Yes.
Eyes up here, everybody. Pencils down. This is really important and I want to clarify it. Shauna, I'll wait for you. You should still have, like your team, you should still have green group. Everyone, eyes on green group over here. You should still have day 1 built, day 2 built, day 3 built, day 4 built, and day 5 built. So that when you're done, how many total will that be? I'll wait for you, Lizette. 1, 2, 3, 4, 5. Not 10 things built, not 7 things built, just 5. Can everyone see green group? Let's give them a round of applause. And if you need more tiles to build 5 figures, please do that. You have now 2 minutes left to build. Go. Not today, you have Valentine's Day.
That's so terrible.
And let's solve that problem. Let's solve that problem.
All counted up together.
Okay, case. Number 1 gets the title. Number 1 gets the title.
Alexis,
Where's number 5?
Wait, you didn't. These are his pizza? Or does he still have his
Well, according to our timer. 1 minute. 1, 2, 3, 4. Okay, and build the next one.
You said 32.
Where's the fourth one? Here.
Now there's a beach house.
But good. Because we're about down to 25 seconds. How many do we have?
Okay, so I made the
Hey, if you have extra tiles in your group, let's put the extra tiles in here. Sandra T, why is it maybe your group didn't get it done? Do you guys have an idea about that? Were you working as a group or were you all doing your own thing? All right, everyone, sit your patatas down. These tiles that you guys have, I'd like everyone to stand on up and push in your chair. Extra tiles right here. You guys are going to do a walk around the room, and I'd like you to view what other groups built. When you are done viewing what other groups built, I would like you to be able to explain what you noticed about all of the figures your friends built. You may go to any group you want. The volume should be this. Go. Fix it, and then leave. Hunter, push it in and start moving around. Go ahead and take a seat when you have moved all around the group. Before you guys decide what you're going to talk about with your heads together, go ahead and take a seat, Shauna. Before you decide what you're going to talk about with your heads together, I want you to think on your own, what is it that you noticed about the tiles we built, and can you explain it using words? Think on your own. And I want you guys to share your thinking with your group. Heads together, tooties up, go.
We built every time that we were doing,
but I think that we really good. Working together. Okay. The thing I noticed about is that it always added one. So it started at 1, on each side, and 2, on each side, and 3. Yeah, so I kept going on. That's the same thing I did. It just went through, then it went add one more, then add one more, add one more, then add one more, and it got to 1, 2, 3, 4, 5.
Function. A function is a rule that works. Function. Go ahead and take a seat. I'm going to pull out one color. Da-da-da-da, and one number. Number 1. Please stand up. Can you tell us what your group talked about? And can you maybe paraphrase what you heard some of your group members say?
We agreed on all the sides add up 1, but Gabe said that every time the pattern continues, it adds 3.
Well, what?
Okay.
Actually, it's 1.
Well, actually, tell number 1 there, and she will say it for you.
He said that it all adds up to 1.
And what did Alexis say? Did she say anything different?
No, we all agreed that it adds 1 on each side.
Okay. What do you guys think about green thinking? Would that be the way that you would explain it? So today you guys did a ton of things. You represented things in numbers, represented things in words, and you represented things with pictures. I know that eventually we're going to play a workplace game that's called What's My Rule, where you actually have to figure out the rule or the program or the function that's at work and actually play a game against one of your partners. To learn how to do that, you'll first play the game against me. Before we end our lesson, does anyone else have anything that they feel they'd like to add that you didn't get your color or your spoon picked up? Yes, Lizette.
What I thought was that when you add 1 on each side, it's like a calendar.
Yes.
Because you add 3 and it added 3.
Did anyone else make the connection that we were representing the calendar with our arrangements that we were building? Very good. Who else had their hand up that I didn't pull out your number or your spoon? Nick, what do you want to add?
I think that the pattern was times 3 plus 1.
Times 3 plus 1. Anyone agree with that? All right. Hunter T.
I think it related to the calendar. In my group, the green square on day 1, it was just 1 square, and every time it went up by 1, just like right here.
Did it follow your observations and predictions of 3 plus 1 or multiplying on another number?
Yeah.
Okay. Anyone make that connection as well? All right. Izzy.
I've noticed that number 1 has 1 tile on one side, and then number 2 has 2 tiles, and then 3 and then 4 and then 5, so it just keeps growing and growing.
All right. The last thing I wanted to do was I would like us to build the 26th. Eventually, you guys are going to get tiles in your group. When we come to the 26th, we'll actually build that tile arrangement. It's going to be pretty long, isn't it? Might have to build it on the floor.
Yeah, maybe.
Can someone go get a Post-it note from my group so we can put a star on this? Thank you, David. Hunter, he's on my desk. He knows where they are. He's using this observation. And we'll mark it with a pink star that will tell us we have to build that one. 26. We're going to build that tile arrangement. All right. Thanks. And I'll stick it on this side. That way, if we forget, it'll be like, oh, I forgot. Now I remember. All right. Number 2s and number 3s, you're going to be in charge of picking up your tiles and going and putting them back inside the containers. Number 2 and number 3.